Alright, so in this video we're going to talk about how to use these trig identities and meaning most commonly the three Pythagorean identities that you see here, how to use those to find other values in a triangle. Okay, and this is basically a three-step process. We have to figure out which is the correct identity to use out of those three. And then we will use those other identities, the sine-cosine relations, meaning tangent is equal, for example, to sine over cosine. Cotangent is equal to the reciprocal of that, so cosine over sine. And we also know that cosecant is 1 over sine, and we know that secant is 1 over cosine. So we're going to use those identities to find exactly what they're asking us for. Okay, and then we also have to use this idea that we've talked about. All students take calculus, meaning everything is positive in the first quadrant, sine is positive in the second, tangent in the third, cosine in the fourth. Alright, so the first step, locate the correct Pythagorean identity. So here's how we locate that. We use what they're giving us. They're giving us sine, so we're going to use the identity that has sine in it. Okay, and what is that going to enable us to do? Well, this has cosine in it as well. So if we plug in sine right here, we will be able to find that, which is what we're being asked to find. So we'll start by plugging in sine right there. So let me just move this over so we have a little bit more space to work with. Alright, so sine squared plus cosine squared is equal to 1. So let's plug in. They're telling us sine is negative 5 over 9. So I'm just going to plug in negative 5 over 9 here and square it. And then we have our cosine squared equals 1. And now we just need to simplify this as we typically would. So negative 5 squared is 25. 9 squared is 81. Okay, and then let's change 1 into 81 over 81. And the reason I'm doing that is because the next thing we have to do is we have to subtract this from both sides, meaning we would need a common denominator. So that goes away. We get cosine squared is equal to 81 minus 25 is 56 over 81. And then the last thing we need to do, we want to solve for cosine, not for cosine squared. So what we would do here is square root this side, and we would square root this side, and whenever we take the square root we put a plus or minus in front. So plus or minus square root of 81 is 9. Square root of 56, if you look at 56, a perfect square goes into it. It turns out to be 4 times root 14, which is the same as 2 root 14. Okay, so we found out that cosine is either positive or negative 2 root 14 over 9. So let's come back up here. Okay, how do we tell if it's positive or negative? 2 root 14 over 9. How do we tell if it's positive or if it's negative? Here's how we tell. Okay, and actually I put 3 steps up here. This is really step 3, but we'll skip ahead. Find out which of the 4 quadrants we're in. So we know that we're in a quadrant where sine is negative, and that means we have to be in either this one or this one, because sine is positive in the first and second. We also know that we're in a quadrant where cotan is negative as well, because that says cotan is less than 0. That also means that tan is less than 0, because whatever cotangent is in terms of positive or negative, tangent is also. So out of quadrant 3 and 4, where is cotan negative? It's negative in that quadrant. So we must be in the 4th quadrant right here. And we're being asked, one of the 2 things they're asking us is cosine. What is cosine in the 4th quadrant? Cosine is positive. So we can get rid of this plus or minus. We know it's going to be plus. Okay, cosine is positive 2 root 14 over 9. Now let's find cosecant. Cosecant is even easier to find in this case. We don't actually have to do any math. We know up here that cosecant is 1 over sine. So we know that sine is negative 5 over 9. That means cosecant is negative 9 over 5. We just find the reciprocal. So I encourage you to try to pause the video and see if you can do the next one right here, this other example, which is an example using cosine and cosecant, but this time they give us tangent to start. All right, so let's see if we can do this. I'm just going to move some things around here so we have a little bit more space. Okay, these problems tend to involve a lot of work, so we need as much space as we can get. Okay, so the first step, locate which identity we need to use. Well, it's based on what they're giving us. They're giving us tangent, so we want to use this one because that has tangent in it. Okay, so let's use tan squared theta plus 1 equals sec squared theta. We proved that in the other video, but you don't have to prove it for this. You just have to use it. And what is tangent? Tangent is 5 over 7, so I'm going to plug in 5 over 7, and that's what I'm squaring. and that's equal to sec squared. Now you might say, why are we doing this? It's just going to give us sec squared, and that's not what we want. We want cosine and cosecant. But think of it this way, if we know secant, it's very easy to find cosine. And why is that? Because secant and cosine, there's the relation. They're just reciprocals of each other. All right, so let's keep going. So 5 over 7 squared is going to be 25 over 49. And then I'm going to change 1 into 49 over 49 because we need a common denominator. Okay, 25 plus 49 is 74 over 49. That's equal to sec squared. And to solve that, we just need to square root, and we need to square root, plus or minus. So that's going to be plus or minus. There are no perfect squares that go into 74, but square root of 49 is 7. So this is what secant equals right here. Secant is either of those two. Let's skip ahead again to the third step. Okay, it really should be the second step. Figure out what quadrant we're in. So how do we do that? What we did in the previous example was we figured out, first of all, we narrowed it down to 2. So tangent is positive, and that happens here and here. So we must be in the first or third quadrant, but we're also in a quadrant where cosine is positive, and cosine is not positive in that quadrant. It's positive in the first quadrant. So we're in the first quadrant. That means everything is positive. So secant is positive here. So let's find these other two things. So cosine is just the reciprocal of secant. So in that case, cosine is going to equal, cosine of theta is the reciprocal of this, which is 7 over root 74. And we can multiply the top and the bottom by root 74, and that will give us 7 root 74 over 74. So there's the cosine right here. Cosine is that. Now how can we find cosecant? Well, if we knew what sine was, we could easily find cosecant. And why is that? Because, let's just travel up here a little bit. If we knew what sine was, here's the relation between cosecant and sine. So that's one way we could do it. We could find out, actually that's using identities, that's really the only way we can do it in this case. There's probably another identity we can use, but that might be the easiest way. So let's find out what sine is. Actually, you know what? I misspoke. We can use this identity because we know what tangent is. So let's plug in tangent. Sorry, I'm looking at the wrong one. We know what tangent is, so we can use this identity because if tangent is 5 over 7, that means cotangent must be 7 over 5. So we will plug in cotangent, and that will give us an easier way to solve for cosecant. You can use any one of these identities as long as you find a way to connect them together. So 7 over 5 is like 49 over 25. And then I'm going to write the 1 right here as 25. Let me bracket that off here. 25 over 25 plus 49 over 25. Okay, and that means that this thing simplifies to 74 over 25. And the last thing we need to do is square root and square root. We would put a plus or minus, but we know we're in the first quadrant, so we know it has to be plus. So that's going to be square root of 74, and then square root of 25 is just 5. So there is our cosecant, and we found the cosine right here. So we're done.